Various organizations have tried donating these expensive incubators in rural areas, in developing areas in India, Bangladesh, Nepal, Cambodia, Vietnam, and Indonesia. However, it's been found that within a few years, incubators are broken and inoperative and are discarded or used simply as storage devices. A study led by Robert Malkin in the bioengineering department at Duke found that 98% of donated medical equipment in developing countries is broken within 5 years. And no one in those places knows how to do the repairs on these exotic-looking machines. The people in these areas have neither the parts nor the know-how. So the students at Design That Matters had a breakthrough when they followed the guidance of Paul Hudnut, who said that there are 3 products you can find anywhere in the world. You know what they are? Coke, cigarettes, and car parts. Even in the most rural areas of developing countries, you can find people who know how to fix cars. The team at Design That Matters constructed an incubator based on car parts, so that if you knew how to repair a car, you could fix the incubator. The warming system consisted of 2 car headlights and a blower from the heating fan in the dashboard of a car. The car door chimes and the small lights in the door were used to make an alarm system for when the infant's temperature deviated too much. A motorcycle battery was used to power the incubator during power outages and for transport from home to the clinic. This incubator really works, and it can be repaired and maintained by local car mechanics. Once again, an elegantly simple concept led to this innovation. I'm a firm believer that innovations are more likely to occur when a person has expertise in 2 different areas. And these areas can be somewhat unrelated. Last year, I decided to study innovations that led to important medical discoveries. One of the most interesting and romantic stories I found was the discovery of digitalis. It's an important cardiac medicine used today. In 1780, William Withering, a young British physician, set up a practice in the small town of Stafford in England. He fell in love with one of his patients, Miss Helena Cook. I don't think you're supposed to do that. She was an artist who specialized in paintings of flowers. Although Withering had disliked the subject of botany during his undergraduate training, in order to win the heart of Miss Cook, he developed an intense interest in wandering through the English countryside collecting flowers. He became skilled at identifying the flowers, and he knew where to find each species. Withering's clinical specialty was in the diagnosis of heart failure, or dropsy. He had one particularly frustrating patient, an elderly woman who was, in Withering's estimation, terminally ill with heart failure. Withering told her there was nothing further he could do, and he sent her home to die. She came to him 6 months later and had experienced a remarkable recovery. On further inquiry, Withering learned that she had been ingesting a secret concoction of herbs created by an old gypsy woman. Withering contacted the woman and paid her to divulge the identities of the 20 or so herbs in her concoction. Through his expertise in local flowers, he traced the active ingredient to the foxglove plant, which has beautiful purple flowers. From his hillside quests, he knew exactly where to find foxglove in great abundance. So he then began treating patients with defined doses of ground, dried foxglove leaves. And over the next few years, he worked out the dosage of how many leaves would have a beneficial effect and avoid toxicity. The active ingredient in the leaves was digitalis, of course, which later was isolated by chemists. By having expertise in 2 different areas, flowering plants and heart failure, Withering was able to make a connection and create an innovation that others might not have made. So innovation is easier if you bring a new perspective to a problem. One way to foster innovation is to encourage training in 2 different areas, whether they be medicine and science, medicine and engineering, medicine and public policy, etc. And obviously, this group embraces this concept. A work environment in which there are people with different backgrounds working alongside each other is another way to foster this kind of cross-fertilization of fields and lead to innovation. Innovations can arise in strange ways. I'd like to tell you a brief story from my own experience. My colleague Lee Douglas and I founded Core Therapeutics in 1989 for the purpose of discovering new medicines to treat coronary artery disease. We knew that myocardial infarctions, heart attacks, were often caused when platelets aggregate in the coronary arteries. We wanted to find a way to rapidly block platelet aggregation. The surprising part of the story is that we found the medicine in snake venom. Core scientists reasoned that when a poisonous snake bites you in the foot, for example, the venom wouldn't be able to circulate through your body if there was a clot that formed at the site of the snake bite. Therefore, the venom might include an antiplatelet agent which could prevent the clotting of blood locally. Maybe this substance could also block platelet formation, platelet aggregation in coronary arteries. We found a snake farm in Florida where the proprietor, an 80-year-old man named Ross Allen, had been collecting rattlesnake venoms for most of his life. And we purchased all 62 of his venoms and screened them for antiplatelet activity. Bingo! One of them had very potent activity in our test tube assay. Robert Scarborough, a core scientist, isolated the active ingredient and used it to make a drug called Inaugural. This drug is frequently used today for people who have impending myocardial infarction or unstable angina. The point of this story is that innovation came from a team of people who were confident and fearless enough to take an unorthodox approach to searching for a new medicine. Innovators have to be willing to make mistakes and need to be in an environment where mistakes are permissible. In his book, Where Good Ideas Come From, Stephen Johnson has said, "The history of being spectacularly right has a shadow history lurking behind it, a much longer history of being spectacularly wrong again and again." One example, in 1951, Wilson Greenbach, a self-taught expert in electronics, had coffee with a surgeon who told him the problem of people who had arrhythmias and their heartbeat wasn't stimulated frequently enough. 5 years later, Greenbach was hired by a medical institute in Buffalo, New York, to develop a diagnostic instrument which could record heartbeats. The device he was building had an oscilloscope as part of it. One day as he was working on the device, Greenbach reached into a box of electrical parts and happened to pull out the wrong resistor. When he plugged in his device containing this wrong resistor, he noticed the oscilloscope was pulsing at a rate similar to a human heartbeat, even though there was no heart attached to it. Suddenly, he had the idea that he could use this device in reverse. Instead of recording heartbeats, maybe he could use the device with the help of his surgeon friend to implant electrodes to stimulate the heartbeat. This was the birth of the electronic pacemaker, the cardiac pacemaker, which has saved millions of lives. So he not only made a mistake by using the wrong resistor, he used the mistake to his advantage. Stephen Johnson has gone on to say that error is not simply a phase you have to suffer through on the way to success. Error often creates the path that leads you out of your comfortable assumptions. Being right keeps you in place, being wrong forces you to explore. In 1874, the British economist William Jevons described the importance of error in his book, Principles of Science. He noted that errors of the great mind exceed in number those of the less vigorous one. So the smarter you are, the more errors you make. I frequently take solace in this. Now, I'm not recommending that you go out and make lots of careless mistakes, like giving a patient the wrong dose of medicine or operating on the wrong kidney. I'm talking about a situation in which you have used all of your available information, you're perplexed, and you try something new, and you learn from your errors. Along these lines, I have a quote that I like from Michael Jordan, and I have to reference a Nike commercial for this. One of the greatest basketball players of all time, Michael Jordan. He said, "I've missed more than 9,000 shots in my career. I've lost 300 games. 26 times I've been trusted to take the game-winning shot and missed. I've failed over and over and over again in my life, and that is why I succeed." Now, I've spoken to you about innovation, and now I'm going to be innovative as a graduation speaker and finish on time. Before I close, I'd like to express my thanks for being able to celebrate this wonderful occasion with you. You, the students, are in an enviable and unique position. The first class of a first-class school. Your progress and success will be noted. You have a tremendous responsibility of being the pioneer class and also the responsibility of being a physician. Society has placed great trust in you, and from what I've seen today and of your class, this trust is well placed. Congratulations.